Hello, in this video I'm going to solve the following problem for you. Solve the following equation in radians. 1/2 plus 16 to the sine x equals to 6 over 4 to the 1 minus sine x. Express your answers exactly and in radians. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the problem correctly, one possible set of answers that you might get is as follows. X equals to n pi, x equals to minus pi over 6 plus 2n pi, and x equals to 7 pi over 6 plus 2n pi. Of course, here n is an integer. Okay, now let us try to solve the problem on the board. Okay, in order to solve this problem, you see that's a trigonometric power equation. It's trigonometric because the unknown is an angle of a trigonometric function. It's a power function because your unknown appears as the exponent, yes? So if you want to solve that problem, might be introducing an auxiliary variable would be helpful, because if you see, this is 16 to power sine x, 16 to power sine x can be viewed as 4 to power 2 to power sine x. And then you know that you can flip these two, so this becomes 4 to the sine x to the power of 2. Yes? And here you have 4 to the power of 1 minus sine x, and you can write it easily as 4 divided by 4 to the sine x. Yes? Because the exponent here is 1, the exponent here is sine x, the bases are the same, so if you divide, you subtract the exponents and you get this back. So you see that 4 to the sine x appears in this combination as well as in this combination. So it is already motivating you. It would be a good idea if I call it a new variable. So I would say that let 4 to the sine x be equal to x. This is an auxiliary variable. Using this, I reduce the problem in a problem that looks simpler in form and try to solve that. When I find capital X, using capital X, I can eventually find my little x, because that problem becomes simpler than the original problem. Okay, so let us do that. So I rewrite this equation, 1 over 2 plus, I just told you 16 to the sine x is this, but I call this capital X and I have an exponent 2, so this becomes nothing except capital X to the power of 2. And on the right hand side I have 6, and then here I can write it as 4 divided by capital X. Okay, and that is a very simple equation to solve. For example, let me first get rid of this compound fraction here. So this becomes 1 over 2 plus x squared equals to. This x will go there, so it becomes 6 capital X over 4. 6 and 4 can be simplified by 2, so this becomes 3x over 2. So x goes down, and 6 and 4 are simplified, 3x over 2. In order to get rid of the last fraction, I prefer to multiply everything by 2. So if I multiply this by 2, it becomes 1 plus 2x squared equals to 3x. And that's extremely simple quadratic equation to solve. So I bring this to the left and organize it. And for example, I use ABC formula to find capital X. So capital X is minus b, which is 3, plus or minus the square root of this number squared, which is 9, minus 4 times this times that, which is minus 8, divided by 2 times this number, which is 4. 9 minus 8, 1, square root of 1 is 1. So it becomes 3 plus or minus 1 divided by 4. And I get two values for x. 3 plus 1, 4 over 4, 1. 3 minus 1, 2, 2 over 4, which is a half. Okay? But these are the values of the capital X. My goal is to find the little x. Okay, that's a very simple one. So remember this definition of capital X. So what we do, you say that, okay, if capital X is 1, it means that 4 to the sine X is 1. Okay, 4 to a power is supposed to be 1. This cannot happen unless the exponent is 0. So sine X is equal to 0. Okay, if sine X is equal to 0, it means that it is either a multiple of pi or a multiple of 2 pi. Yes, so in principle, any multiple of pi is acceptable. Sorry, it's an even multiple of pi, because if you want to have sine X equal to 0, it means that you have to have the y coordinate equal to 0. So it means that either you are here or there. If you are here, you are X is an even multiple of pi, and if you are here, X is an odd multiple of pi. So it means both even and odd multiples of pi are both acceptable. So instead of writing them separately, I would simply write X is equal to any integer multiple of pi. Yes, of course, n should be an integer. I will emphasize at the very end. The next problem, the next part is X equals to 1/2, capital X. So this, again, by the same definition, so 4 to the sine X becomes 1/2. Okay? So this is base 4, this is somehow base 2. I want to make them the same base so that I can compare the exponents. It's very simple. So 4 to the sine X can be viewed as 2 to the power of 2 to the power of sine X, and 1/2 can be viewed as 2 to the power of -1. And now what happens, the left side becomes 2 to the 2 sine X equals to 2 to the power of -1. I have two powers, and I have equality between them. The bases are the same, so this can only happen if the exponents are also the same. So 2 sine X equals to -1/2. So what happens? Sine X becomes -1/2. And now I have to solve this very simple trigonometric equation. And we know that X is equal to sine inverse of -1/2 plus 2n pi, which of course sine minus a half, sine minus -1/2 is minus pi over 6, and then I have plus 2n pi. Yes, and the other scenario is that X is equal to pi minus this number, okay, but this is again minus pi over 6 minus minus plus, so it becomes pi plus pi over 6 plus 2n pi, and if I take the common denominator, it becomes 7 pi over 6 plus 2n pi. Okay, so that is one group of answers, that is another group of answers, and that's a group, this is another separate group of answers. So n also should belong to the set of integers. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.